In this video, one will be able to understand the representation of complex numbers and their operation in different calculators. So let us see how or understand the difference between rectangular and polar form, which are very useful in solving numericals and understanding the representation of voltage and current in a sinusoidal waveform. So here we have representation of a complex number and a polar form, a complex number in terms of rectangular form and polar form. The complex number in terms of rectangular form is given as 4 plus j5, and the polar form in terms of 6.430 at an angle 51.34. So let us understand one by one. So rectangular form of a complex number, where a complex number is denoted by its respective horizontal and vector components. In order to distinguish the horizontal and vertical dimensions of each other, we use the component called I or j. So this is how we generally represent the real part and imaginary part of a given complex number. So 4 is the real part which comes along x-axis, and plus j which comes on plus y-axis, and this point is where we have 4 plus j5. And how do we convert this into rectangular form, or what is 6.430 and 51.34? So the magnitude from the origin to the point 4 plus j5 is actually 6.430, its magnitude. And the angle from x-axis is 51.34. So how do we convert rectangle to polar form mathematically? So square root of 4 square plus 5 square would give you 6.403, which is nothing but the base and hypotenuse. It gives you the base and opposite side gives you the hypotenuse. I repeat, the base and opposite side gives you your hypotenuse. And the angle is given as tan inverse of 5 by 4, which is 51.34. So one can use this or simply use a calculator, which we'll be discussing in the upcoming slides. So let's see how do we convert now the polar form to a complex number. So the length, what we have found is 6.403. So let's try to convert it back into 4 plus j5. So that's its magnitude, and the angle is 51.34. So let's see how do we convert polar to rectangular form. So 6.430 into cos of 51.34 would get back your real part, that is 4, and similarly 6.430 into sine 51.34 would give you your imaginary, that is 5. So rectangular form to polar form, one has to understand what all points must be kept in mind. You can only add and subtract the real part and the imaginary part respectively. I repeat, you can only add and subtract the imaginary part and real part respectively. So let's take an example. 1 plus I2. Now in calculator, we cannot substitute 1 plus I2. If you try, you get syntax error. So let's try this. So let's say the question is given in such a way that you find a numerical where the values of impedance or voltages or current are given, and we need to add them. So if you have everything in rectangular form, we can add them, add respectively the real parts and the imaginary parts. So if you add, you'll get 1 plus 5 minus 2 plus 2 minus 4 plus 3 in terms of imaginary part. You get 4 plus 1i. So what you have to remember is the syntax in calculator is a plus or minus bi, but not a plus or minus ib. So when you write, we type or write as 1 plus I2 or 1 plus or minus IB, that is a plus or minus IB, right? But when you type in calculator, the syntax is a plus or minus BI. So you can see in the given question A, where it is 1 plus I2, but in calculator we have to type 1 plus 2I, right? So now how do we convert this to polar form? So let us see using these two types of calculators. So here, as we discussed, so go to mode, plus 2, there is a complex number, type 1 plus 2I, you can get here. So if you type I2 and then plus equal to, you can see you'll get syntax error. It has been predefined in calculators, the syntax of complex number, that is simply a plus or minus bi. So it is 1 plus 2I. So now go on, substitute the other values, that is 4 minus 5 minus 4i and minus 2 plus 3i. So you get the answer 4 plus I. So how do we convert to polar form? So in this particular calculators, what you have to do, you have to go to shift, and then you can see complex associated with number 2. So click on button 2. Now we have typed in a plus bi, we want as r at an angle theta, so click 3. When you press equal to and press SD button, you get the answer in terms of polar form. So 4.123 at an angle 14 is your answer. So now let us see another calculator, 991EX. How do we solve the same? The syntax remains same in this calculator also. That is a plus or minus bi. So go to mode, press right arrow or press 2. You can see I symbol which says that now it's in the complex mode. So I again same associated with eng. So just showing you the syntax. It's again it's same in this calculator or any calculator, the syntax is same. That is a plus 2i. That is a plus bi. So go on, type 1 plus 2i plus 5 minus 4i minus 2 plus 3i. You get 4 plus i. Now to convert this to polar form, click on option and then press down arrow. You can see option 1 associated with r at an angle theta. So click on 1 and then equal to. So there you go. It is 4.123 at an angle 14.036. So let's see how do we convert rectangular form to polar. We have just seen. So 10 minus I8. So you get syntax error. Why? We have to type as 10 minus 8i, not 10 minus I8. So this is how you get that's how you see in the papers, right? So we know syntax how to be typed in your calculators. So let's say 91E1S plus. Please ensure that whenever you're solving a problem in single phase AC and three phase AC, you have to reset your calculators. That is what I've done earlier. I've just shown you how we have to reset the calculator and then type in the syntax prescribed, that is that is a plus or minus bi. So then in this calculator, press shift and then button 2, which is also with complex number, and then since I need to count rectangle to polar, click on 3 and then equal to. So there you go. We have 12.806 at an angle minus 38.56. Similarly, 10 plus 50i, same pattern. If you solve, you get 50.99 at an angle 78. I hope you can do for the last one, 20 plus 45i. So let's see how can we solve the same with respect to 991EX. So please reset your calculators by pressing shift and 9 and then equal to by pressing number 3, resetting all, and then go on to more menu and you can select the mode for complex number. So just showing you the syntax is same. There's a plus or minus bi. So 10 minus 8i. In this option, you have to go to option. In this calculator, go to option, press down arrow, click on 1 as we need to convert from rectangle to polar. Similarly, you have to use same syntax to solve for 10 plus 50i. Go to option, down arrow, 1, which converts rectangle to polar, and then equal to. So I hope you have tried solving for 20 plus 45i. So if you do that, you should get the answer as 49.244 at an angle 66.0375. So if you have observed that we have taken imaginary negative for 8i, thus you can see the angle is also negative, and here the angle is the imaginary part for your 10 plus 50i is being positive, thus the angle is also positive. Similarly, the imaginary part for the third one is 20 plus for the equation 20 plus 45i, the imaginary part is being 45, and you can see the angle is also being positive. So both are associated in the sense, if the angle is positive, we get magnitude, we get the imaginary part positive, vice versa is also true in this case. That is, if you can see, we have substituted imaginary as -8, we've got angle as -38, and the imaginary part being +50, we've got angle as +78.69. The imaginary part being +45, we've got the angle as +66. Okay, so assuming that you have reset your calculators, two. So in this calculator, it is to click on angle, you have to press shift and then ENG. So if you multiply in this way and then convert, this is 991EX. I repeat, it is 991EX. So you get 12 at an angle -2. So here I have shown you a case where to when we divide. So two by 6, what do we get? 0.33, and -5 goes to up, becomes +5. So you should get the answer as 0.33 at an angle 8. So you can try using these calci. So always ensure it's in complex mode, it's in degree. So always what you have to reset your calculators, right, by initializing everything, go back to menu and then select 2. That's your complex mode. Now you can simply use parenthesis to type 2 at an angle 2 at angle 3 divided by 6 at an angle -5. The syntax will be taken care by calculator, what to divide, what to add, what to subtract. Shift and then ENG to get the angle, or if you press only ENG, you will get I. Okay, and if you click OK, I'll get it in rectangle form. Since I need to convert, I'm going to options and selecting R at an angle theta. Thus I get 0.33 at an angle 8. A simple exercise just to be comfortable how do you convert polar to rectangle. So as you can see, it's always better whenever you're starting, you need not do it every time. Whenever you're starting to solve a sum on single phase AC and 3-phase AC, it's better you reset your calculators. So then at an angle 45, in this calci shift and 2, that's complex number, and I have to press button 3 since I want the answer in terms of R at an angle theta. I want in terms of A plus BI, so I'm sorry, it is 4. So you get 7.07 plus 7.07. Similarly, 25 at an angle -50, and then go to shift, then button 2. Now option 4 equal to, you get the answer as 16.069 minus 19.15. So I'm doing the fourth one, that is -8. Now here it is -8. You can see how I've typed. Please use parenthesis. If you just type -8, you'll get math error. If you just type -8 at an angle -55, I repeat, you'll get math error. So to avoid that, what you have to do, you have to use brackets. Why? Because 8 is actually magnitude, and magnitude cannot be negative. So we want to find negative of the answer. So for that, please use parenthesis, or else you'll get math error. As you can see, if I substitute -10 at an angle 82 without using parenthesis, I'll get math error. So use parenthesis to find the negative of the vectors. So similarly, let's see. So 10i, 10 at an angle 45, and then go to option. In this calculator by default it is set, so no problem. Or else if you want in a plus or minus bi, what you have to do, type 10 at an angle 45, go to option, press down arrow, and then click on the button associated with a plus bi, that is button 2. So if you see here minus 8, if you're typing minus 8, if you're typing minus 8 at an angle minus 55 plus equal to, you'll get math error. What you have to do, you have to type minus parenthesis, that is bracket, 8 minus 8 at an angle minus 55, and then close the bracket. To get your answer. So I hope you can try first all. So you can see here minus 8, what you have to do, minus bracket 8 at an angle minus 50. Thank you for watching the video. Please subscribe for the YouTube channel and to enrich and enhance your knowledge.